Good morning.
Good morning.
All right, so today for our math lesson, we are going to start out by talking about equal grouping, okay? So we're going to do a little activity before we get started on the actual lesson. And what I want you to do is show me how you would draw 3 groups with 2 in each group. So draw 3 groups for me with 2 things in it, like X's or balls or whatever you want to do.
So, like circles or anything?
Mm-hmm. Good. Okay, so you've drawn 3 circles with 2 X's in each one. So how many X's do you have total?
6.
6. Good. Okay, now, I'm going to erase this with, don't I? Okay, let's try another one. Now I want you to draw 3 groups with 1/2 in it, in each group, okay?
One half,
Like the fraction 1/2.
Okay.
So if you write a half here, yeah. Good. Okay, now you drew 1/2 in each of your 3 groups. So how many halves do you have in all?
3.
3. So what would that be? How would you say that? If I have 3 halves, how many halves total do I have? Like, how would you say it as a number if you added them together?
2/3.
No, think about it this way. If I have a half and a half and put those together, what's that make?
Half.
If I have half of an apple and half of an apple and I put them together, how much do I have?
A whole number.
A whole. So put 1 down here. So you have 1 whole and then you still have a half, right? So total you have 1 1/2, right? Okay, does that make sense?
Yeah.
Okay, let's try one more. You can just leave your 3 circles. We'll just erase this. Or you don't have to draw as much. Okay, so now I want you to draw 3 groups with 2 1/2 in each group. Okay, good. Now, you have 2 1/2 in each group, so how much do you have total?
4.
So let's add them together. Let's not worry about the halves first, okay? What's 2 plus 2?
4.
Plus 2 more.
6.
Okay, so write the 6 right there. So you have 6 holes. All right. Then you have a half plus a half, which we already did. We said that's a whole. So add another hole to that. And then we have 1/2 left, right? So 6 plus 1 whole is 7, and then our half. So we have 7 1/2 total, right? Okay, good. Okay, so now we're gonna come together with the rest of our class, our imaginary class. And we are going to actually start our lesson. It's kind of windy out here, isn't it? Okay, so for our math message today, I want you to try to solve, you know what, I'm gonna let you write on this. It's all nice and solid. I want you to try to solve these 2 area problems, okay? And so in each of these, have you done area before?
Yeah.
Okay, so in each of these, a square, the little squares are a square unit, okay? So you're going to find the area of the bold print rectangles, okay? And then I want you to think about all the things that you know about finding area, okay? Normally I'd have you do this with a partner so you could talk about it. Okay, go ahead. Good. Okay, so let's give you just a little bit. Think about what you know about area, okay? I'll give you just a minute to think. Okay, can you tell me what area is?
It's where you multiply the two numbers.
Okay, and what are those two numbers usually a measure of?
The side and top.
Uh-huh. Another word that we use for those is the length and the width, right? Okay, good. So area is the length times width, and what are we finding when we multiply those two numbers? What are we trying to find when we find the area?
We're trying to find the width.
Well, that's one of our numbers that it gives to us. We're actually trying to find all the space that's inside this boundary, right? It's closed in, so it has a boundary, and we're trying to find how much surface is in there, right? All that fits into that square. Just like if we put a fence up around the yard, our area would be how much yard is there inside the fence, okay? All right, so that's one of the things we're trying to find when we do area. Now, we want the area to cover, it's easier if it covers whole squares like this, right? It's a little bit harder, like here, see how it only covers partial squares? That's a little bit more difficult, isn't it? And we also don't want our squares to overlap, to be on top of each other, and we shouldn't have gaps. So we shouldn't have like this and then skip a space and some more over here, right? Okay, so, why is it easier to find the area of squares and rectangles?
I think it's because length times width, it's, when you multiply it, you can get the, answer easier.
Yeah, that's true. And it's easier because these little squares fit into a square or rectangle perfectly, don't they? So if you were trying to find the area of this and all you had instead of these little squares were circles, would it be very accurate? Why not?
Because, wait, would you have the numbers?
You might have the numbers, but you still have circles inside here instead of little squares.
It wouldn't because the squares aren't equal.
Okay. It'd be because the circles wouldn't fill in that whole, each of these whole squares, right? Because if you had a circle in here, say like that, I've got little corners there that are not covered up, right? So I'd have gaps and stuff. So we don't want to have gaps, and we don't want to have any overlapping, like any on top of each other, right? We want it to be a flat surface when we're doing area, okay? So let's look back at these and see how we did with finding the area of these, okay? So this one, we had a length of 4 units and a width of 3 units, and you were right. 4 times 3 is 12 units, okay? Now, when we're writing area, we always label them in units squared. Good. Let me add that on here. So this would be units squared because we're using squares to figure it out, right? Okay. Now let's look at this one. What did you say the area was for this one?
6 1/2.
Okay, how did you get that?
I added the 4 plus 2 and then the half.
Okay, but in this one you multiplied.
Oh.
So what do you think you need to do different over here?
Multiply the 4 and 2.
Okay, but then we have that half on there. So how are we going to measure these halves down here? Because those aren't full squares. What's another way we could do that?
Add.
We could add them. So let's try it this way. How many full squares do I have in that inside that dark rectangle?
8.
8. So this is actually going to be 8. But then I have these 2 half squares here. How do I know that they're half squares?
Because they aren't a full square.
They aren't a full square, but how do I know they're not a fourth of a square or a third of a square?
Because it's 1/2 of a square.
Yeah, because it tells me right here in my number, doesn't it? It tells me that the length of this is 4 1/2 squares. There's 1, 2, 3, 4, and then these have to be halves because it's in my number, okay? So I have a half a square and a half a square. So if I put those together, what would it make?
whole number?
A whole number and make a whole square. So I've got to add that whole square to my 8. So what's my answer?
9.
9. So it'd be 9 units squared. So now we're going to work on today finding the area of rectangles that have fractional side lengths instead of just whole side lengths, whole number side lengths, okay? So let's look at this first rectangle, rectangle A, and I want you to find the area of that rectangle for me. And then tell me how you did it. Okay, so what'd you get?
36 units squared.
Good, 36 units squared. And how did you come up with that answer?
I added length. I multiplied length times width, and I got 36.
Okay, good. So you multiplied 4 times 9 and got 36, which is exactly right. Okay, what are some other ways you could have done it if you didn't know how to multiply 4 times 9?
What other way you can do it is you can count all the squares in the box.
Yes, I could have counted all the squares in the box and I would have found there were 36. Or you could even count like each side, and like on this side we have 4, and across the top here we have 9, and we could say, well, 9 plus 9 is 18, and then add another 9, which would be
27.
Yes, and then add another 9.
36.
Yeah. So we could have done it that way too if we didn't know how to do 4 times 9, okay? All right, now let's think about this. So we had one side length that was 4 units and one side length that was 9 units, right? Okay, now let's try this one here. This one doesn't have all the squares drawn in for you, so let's see if you can solve that one. Find the area of rectangle B. Okay, now you're right, that's the right answer. 3 times 5 is 15. Can you write that as a number sentence? Do you know what I mean by number sentence? Okay, so how did you figure that out?
I did 3 times 5.
Okay, you did 3 times 5, so I want you to write 3 times 5 equals 15. That's your number sentence. Right, okay, that's a number sentence, okay? All right, now what's different about this one from this one?
Only 3 boxes are fully equal, and then the others aren't equal by each other.
Okay, it's drawn a lot different, isn't it? But really, we could extend these lines if we were looking at it, because this is really what it means. We could extend that. I don't draw very straight lines, do I? We could extend that straight down like that, because they only drew that top line, but we know it's broken down the rest of the way down, so we can draw those lines in. Now, what's one of the ways I could have done that?
You could have, if you draw the lines, you could have then counted the boxes.
Yeah, I could have just counted each of the individual boxes, and I still would have gotten 15, right? Okay, so let's try another one. Okay, now try rectangle C. Okay, that is the right answer. Now, can you write a number sentence for it? To show me how you got that. Okay, good. So once again, you did just the 6 times 4. You took the length times the width and multiplied them and got 24. Now this one looks different again. What could you have drawn on there if you didn't know how to multiply 6 times 4? What could you have done to that picture?
You could have drawn a line across and across and across.
Yes. Where those dotted lines are, I could have extended those out like this. There. Now I have all my boxes, right? And then what could I have done to solve it if I didn't know how to multiply?
You could count the boxes.
Right. I could count all of the boxes inside the rectangle as well, okay? So now I want you to think about the different strategies that we've talked about. Counting the boxes, counting rows, columns, or multiplying. And I want you to try to figure out how to do rectangle D. It's a little bit different. It's 4 units by 3 1/3 units. Okay, so you said 14 units squared. Can you write a number sentence for it and tell me how you got that? Okay, good. All right, now, you said 4 times 3 equals 12 plus 1 and then plus 1. So how did you get the plus 1 and the plus 1?
So I draw down, and I knew that if there was another box, that would make a 1 hole, and then there would probably be 2 other boxes, so that would be 2 holes, and then I added the 2 holes plus 12.
Okay, so let's draw those lines out so we can see what it would look like. Okay, so there's the horizontal ones. So it would look like this if we drew the lines out, right?
Mm-hmm.
All right, now, you seem to think that these were halves, right? What made you think that?
They weren't full squares, so I thought if you added them, it would equal 1 whole.
Okay, so you thought they were each a half because they weren't full. And so if you're right, if they were half, they'd add together to be 1. Okay, now, here's the problem. What is this number right here?
1/3.
1/3. What do you think that tells me?
That is not 1/2.
You're right, that it's not 1/2. Okay, so actually, each one of these little pieces over here are 1/3 because it tells me going across this row is 1, 2, 3 whole and 1/3. Okay, so now if each of these are 1/3 instead of 1/2, how's that going to change my answer?
2 of these would equal 2 holes, and then 2 of these would equal 2 holes.
Okay, let's think about that. Do you know how to add fractions? Okay, so if I add 1/3 plus 1/3, what's that equal? 2/3, right? Okay, and then I have another 1/3 plus 1/3, right? Down here. So I've got another 1/3 plus 1/3. What's that equal? Now, I have 2/3 plus 2/3, right?
Mm-hmm.
What's 2/3 plus 2/3? Right, it's 4/3.
Mhm.
So now I have, you were right in that there's 12 whole squares here, right? We can count them and see there's 12. But then I have all these 1/3, which actually adds up to be 4/3. So I could either say I have 12 and 4/3, but this is what we call an improper fraction, right? Because my
Mhm.
numerator, my top number, is bigger than my bottom number.
Yeah.
So what could I write that a different way? Could I take a 1 whole out of that?
It would be 12 and 1/3.
It'd be 12 plus 1 and 1/3,
Mm-hmm.
right? Because 4/3 is the same as 1 and 1/3. Because 3 goes into 4 one time, right? And then you have 1 left over. So that's your 1 time makes your whole number, and then you have 1 left over, so you still got to make it that fraction of 1/3. So actually, your answer would have been 13 and 1/3, because you got to add that 1 whole to our 12, right?
Mhm.
And then you have 1/3 left. So the answer should have been 13 and 1/3. So if we wanted to write that as a number sentence, we don't know how to multiply fractions with whole numbers yet, do we? We don't know how to do 4 times 3 and 1/3, right? Even though that would be right, how could we write it out for the way we did it? Can you think of a different way we could have written it out? What about thinking about our rows? How many boxes are in a row?
3 and 1/3.
Yeah, 3 and 1/3. So we could have said for our number sentence, 3 and 1/3 plus, there would be another 3 and 1/3, right?
Mm-hmm.
Plus another 3 and 1/3 plus one more 3 and 1/3, right? Then we can add up our whole numbers first. 3 plus 3 is
6,
plus 3
9,
plus 3,
12.
so it'd be 12. And then we just did all our adding of our thirds over here, didn't we? So that would give us
12 and 1/3.
12 plus 1 and 1/3, right? Because we get 4/3 when we added those up. So our actual answer is
13 and 1/3.
13 and 1/3. Does that make sense? You always got to look when you're doing it at this number, the one that has a fraction with it. If one of them has a fraction, that's going to tell you what size those squares are. Okay? All right. Let's see. Okay, so now let's do some guided practice. I'm going to give you some practice problems to do. And I'm going to kind of sit here with you as you go through them and do them kind of together. Okay. This is the one for the end. Okay, here. So we're going to work on this page together. So up at the top it says, find the area of each rectangle, write a number sentence to show your thinking. So there's your rectangle, and you need to write your answer here and your number sentence. And you can always draw those boxes in if you need to. Good. So you got 6 times 8 equals 48. And they already labeled it for us, so it's square units, because that's how we always label our area. Very good. That one was pretty easy, wasn't it? Okay, now try this one here. It's 7.5 units by 2 units. Good job. So you knew 7 times 2, which is right. That's going to give us the area is 14. And then how did you get that 1 there?
I added both of the halves, and then I got a 1 whole.
Good. And how did you know these were halves?
Because right here it shows us the number.
Right, because up here in 7.5, it showed us that these are half squares, right? Okay, very good. Now let's try another one. Try this one, which is 4 units by 5 1/3 units. Doing a great job. Yeah. Good job. You did great with that. Okay, so you knew that 5 times 4 is 20. And then you figured out, because you remembered to look at what? At the number, what that fraction was. So each of these little boxes up here must have been thirds, right? So you got 5 times 4 is 20. And then there were how many 1/3 boxes up here?
4.
4. So you did 1/3 plus 1/3 plus 1/3 plus 1/3, right? And that gave you
4/3,
which is the same as
1
1/3. And so you added that to your 20. That was really good. Okay, now let's look at this last one. It's drawing kind of funny. Oh, I see what it is. Okay, so this side length is 3 units, and this is 5, and then this small box down here is 3/4 of a unit. So it's 3 3/4 by 5 units. Okay, see if you can find the area to that one. It's a little bit trickier. The way this is written out, just think of it as 3 3/4. Okay. And you can draw lines if you need to. Good. But you know that these 3 boxes, or these 4 boxes right here, are what size?
3/4.
Yes. Okay, so now figure out the problem and write a number sentence for it. You've got the right idea. Mhm. Right. Okay, you almost did the whole thing perfect. The only thing is, when you added your 3/4, and you're right, there's 4 of them, right? Okay, you added your 3/4 and you got 12/4, which is right, because 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. 12, this is the same as 12 divided by 4, right? 12 divided by 4 is what?
3.
3. You just tacked on an extra 3/4 that wasn't there.
Um,
Okay, so we'll take that off. So then all you had to do was add your 15 that you got, because there's 15 boxes up here, plus your 3. What's 15 plus 3?
18.
Yeah. So you should have gotten 18 for your answer instead of 3/4. And sometimes it helps if you draw those boxes out, even if you go back like to check yourself, because you're pretty good with your math. Just count the boxes. So you would have counted 15, and then you would have had the 3/4 at the end to add on, okay? So can you go back and explain to me how you got your answer for number 3?
So what I did was I did 5 times 4,
Mm-hmm.
which that was 20, and then I knew that there was 4 of 1/3, so I had to add 1/3 plus 1/3 plus 1/3 plus 1/3, and then I got 4/3, and then I knew I had to divide 4/3, and that got me to 1 and 1/3, and then I added my answer for 5 times 4,
Mm-hmm.
which was 20. And then I added that plus my whole number and 1/3, and I got 21 plus and 1/3.
Very good. Okay, good job. You feel like you understand how to do it now? Okay, I'm gonna give you 4 problems to do on your own, and then that's how I'm gonna see if you understood it or not, okay? So there's 4 separate problems. I'm gonna let you try to do those on your own, okay? And we'll walk around the room and help the other students. Doing a great job. Keep up the good work. You guys have about 5 minutes left to keep working on your problems. Doing a good job. Okay, y'all finished? Okay, you did a very good job. Thank you for being such a good student today.
Thank you.